Chapter 1. Introducing AI-Assisted Programming with GitHub Copilot. This chapter covers how AI assistants change how new programmers learn, why programming is never going to be the same, how AI assistants such as GitHub Copilot work, possible perils of AI-assisted programming. Computer programming has long been the domain of professionals with special training and advanced skills. After all, you want the applications running your bank, phone, car, and so on to work exactly right every time. Just as room-sized computers with stacks of paper cards and miles of magnetic tape have been replaced by modern devices, programming languages and tools have also become easier to use. And now, artificial intelligence, AI, tools such as ChatGPT put computer programming within the reach of almost everyone. We want to help open this door for you. Learn how to program, and you'll be able to take on new tasks at work, create your own computer games, and put the computer to work for you at your job. In this book, we'll show you how to write your own computer programs using ChatGPT and GitHub Copilot. Along the way, you'll learn some skills in Python, one of the most popular programming languages. Section 1.1. Improving how we talk to computers. Let's start by asking a computer to count from 0 to 9. Decades ago, a book about programming would have asked you to learn how to read and understand the following code, based on this link.
See this code?
We're glad that's not how we program anymore. That monstrosity was written using code in assembly language, a low-level programming language. Low-level programming languages, as you can see, aren't languages that humans can easily read and write. They're designed for computers, not humans. No one wants to write programs like that, but especially in the past, it was sometimes necessary. Programmers could use it to define exactly what they wanted the computer to do, down to individual instructions. This level of control was needed to squeeze every bit of performance out of underpowered computers. For example, the most speed-critical pieces of 1990s computer games, such as Doom and Quake, were written in assembly language like the previous code example. It wouldn't have been possible to make those games otherwise. Section 1.1.1. Making it a little easier. Okay, let's move on. Here's a more modern computer program that also prints numbers.
See this code?
This code is in the Python language, which is what many programmers use these days. Unlike assembly language, which is a low-level language, Python is considered a high-level language because it's much closer to natural language. Even though you don't know about Python code yet, you might be able to guess what this program is trying to do. The first line looks like it's doing something with the range of numbers from 0 to 9. The second line is printing something. It's not too hard to believe that this program, just like the assembly language monstrosity, is supposed to print the numbers 0 to 9. Unfortunately, something is wrong, and it prints the numbers 0 to 8 instead. While this code is closer to English, it isn't English. It's a programming language that, like assembly language, has specific rules. As in the previous code, misunderstanding the details of those rules can result in a broken program. If you're curious, the misunderstood rule was that the range function stops 1 before the second number provided, so it doesn't include the number 9. If you wanted 0 through 9, you'd need to say range of 0, 10. The holy grail of communicating with a computer is to do so in a natural language such as English. We've been talking to computers using various programming languages over the past 80 years, not because we want to, but because we have to. Computers were simply not powerful enough for the vagaries and idiosyncrasies of a language like English. Our programming languages improved, from symbol soup assembly language to Python, for example, but they are still computer languages, not natural languages. This is changing. Section 1.1.2. Making it a lot easier. Using an AI assistant, we can now ask for what we want in English and have the computer code written for us in response. To get a correct Python program that prints the numbers from 0 to 9, we can ask our AI assistant, Copilot, in normal English language like this.
See this prompt?
Copilot might respond to this prompt by generating something like this.
See this code?
Unlike the example we showed you before, this piece of Python code actually works. AI coding assistants can be used to help people write code. In this book, we'll learn how to use Copilot to write code for us. We'll ask for what we want in English and get the code back in Python. More than that, we'll be able to use Copilot as a seamless part of our workflow. Without tools like Copilot, programmers routinely have two windows open, the one to write code and the other to ask Google how to write code. This second window has Google search results, Python documentation, or forums of programmers talking about how to write code to solve that particular problem. They're often pasting code from these results into their code, then tweaking it slightly for their context, trying alternatives, and so on. This has become a way of life for programmers, but you can imagine the inefficiency here. By some estimates, up to 35% of programmers' time is spent searching for code, and much of the code that is found isn't readily usable. Copilot greatly improves this experience by helping us write our code.